A team at AgResearch is in the early stages of a blue sky project set up to design and build a paddock robot. The idea is to construct a small autonomous machine that can carry out various tasks around the farm at any hour of the day or night in any kind of weather. The Rover is being designed to move from a central base station, navigate its way to a predetermined location and carry out a particular series of tasks, such as measuring pasture, applying fertiliser or moving stock. It would then return to its base station for recharging and further use.
The name of the project is the Rover project. I'm building a robotic rover to put it in paddocks to measure a lot of those things that would otherwise be too repetitious or monotonous to farmers to do all the time. We had the original idea back in 2009. Back then, the Mars rover was the big thing. And we thought, hey, if they can put a rover on Mars 60 million kilometres that way sort of thing, then surely we can put one of these things in the paddock. This particular project at this stage was funded by AgResearch through our Curiosity Fund. This is a small fund for bright ideas, blue skies ideas. I think about 8 to 10 people were funded each year. So that's internally. It doesn't matter if you're a scientist or a research associate or a technician, you can get funding if you've got a good idea. The precision we're achieving keeps it in a paddock, but it is far short of what we want to achieve. We know that things like measuring pasture is a pretty repetitious task, and sometimes during the year, while it's very useful information, it can get left behind and you might not pick it up again. The soil side of things, being able to build prescription maps for precision fertiliser application, and there's also the pasture variation side of things. So being able to map out individual urine patches and treat those within, say, 48 hours before the urine nitrogen has converted to the more mobile nitrate nitrogen. So if we can get in there, we can potentially have a big impact on nitrate leaching. Through to sort of tasks like being able to automatically press a button, out goes the rover, tops your paddock at a certain time of year. It wasn't an intended purpose of ours, but the feedback that we've had from farmers is that, particularly from the dairy farmers, is that they'd like something to herd cows. So something that'll get up, that they don't have to get up in the morning, that they can rely on, that'll go into the paddock, slowly bring the cows up while they're getting the shed set up. Ideally, we would like push of a button. So basically, paddock 27, 5 o'clock, press a button, off it goes. And while you're off doing your own thing, it's slowly bringing the cows in. We'd have to have a camera on it. So at a certain point in a paddock, ring an alarm, farmer goes to a screen, checks to make sure the cows are all out of the paddock, and then it just slowly brings them up the race. The basic unit is a 24-volt system, runs 4 240-volt gear motors. That gets auxiliary power on days like today from solar panels. 16-inch tractor tyres, weighs about 150 kgs, and it travels along at this stage at about 5 kilometres an hour. We wanted something that would go nice and slow, because the idea is to get it to a stage where it can run 24/7 with minimal refuelling, if you like. So we're not too worried about speed. In fact, the slower the better for us. So it's something that's going to be crawling around in the background, doing its own thing without very little interaction from the farmer, other than through perhaps results from the measurements, the pasture measurements, the soil measurements, going back to a central hub that the farmer can access via cell phone or TV. A lot of dairy farms have one-wire electric gates or 2 wires. The idea of low profile is to actually go under 2-wire electrics. But yeah, eventually, long term, the idea is that, we're talking 5-10 years into the future here. If we're looking at what smart farms might look like, then perhaps something like this could be part of a farm network where, I don't know, you might even build special recharging and places to go under fences, even automatic gates. At the moment, the rover can cope with 10 to 20 degree slopes, depending on how rough they are. But yeah, it's a 24-volt unit that has the capacity at the moment to double that to 48 volts. So basically double the grunt to what we have at the moment. We've gone for this idea because, in my view, drones can only be used in certain weather, the airborne drones, the UAVs. Days like today might be touch and go for a helicopter, bit of wind. But with this, you can pretty much use it in all weather. And we also have the option that we can put on close ground-based sensors, even sensors that penetrate the soil. So we can program it in a stop-start pattern, so it can actually sample across a paddock. We're looking to work with Callaghan Innovation, Auckland University and Victoria University, some very techy people in those outfits, to basically develop the applications and improve some certain aspects of the robot.
This program was made with funding from New Zealand On Air.